So our notes are solving multi-step equations here, meaning more than one step. We've looked at solving just one-step equations. We've looked at solving two-step equations, and now we're just going to have possibly more than two, maybe only two. We're going to go through those steps, though, those 5 steps we keep talking about. So step 1, draw the line down the equal sign. Let's jump right into our examples. Step 2, we want to change all subtraction to addition. So we're going to change this to a plus negative 23. Step 3 says, do I have the distributive property here? And the answer to that would be no. So we're going to move on to step 4. Do I have any like terms I can combine on either side of my equal sign? And I do in this problem. I know that 5m can be combined with 2m. And I know that because they have the same letter and the same power. So we can go ahead and add those together because they're on the same side. We can combine them. 5m plus 2m is 7m. Bring everything else down and set it equal to what's on the left-hand side. And so now we just need to go about moving to get the m isolated all by itself. So now we're going to start to move some of our terms. And we want to get rid of that negative 23, so we're going to add 23. And whatever we do to one side, we want to do to the other to keep it balanced. And 5 plus 23 would be 28. I can't do anything with the 7m, so we just bring it straight down. And negative 23 and positive 23 is 0. It's gone. Cancels out. Now we want to get the m by itself. And remember, 7 next to m means 7 times m. And the inverse operation of multiplication is division. And what do we want to divide both sides by? We want m by itself, so we want to divide by the 7. So we end up with 7 divided by 7 is just plain m equals, and 28 divided by 7 is 4. And we're done. We solved for m. We could check our work by substituting back into the original problem like we have in our other examples. Let's move on to example 2. Example 2, we're going to draw that line down the equal sign. I have no subtraction that needs to be changed to addition. The distributive property, well, we do have parentheses here, but there's no number in front, which just means 1. So if we distribute that 1 to everything, we know it's just a 1s plus 4 plus 2s equals 67. Remember, the 1 is only distributed to what is inside the parentheses, and it doesn't change the value. There is really no need for parentheses there. Now we need to check after the distributive property to see if we have any like terms we can combine. On the left-hand side, I see I have a 1s and a 2s. Those can go together. 1s and 2s would be 3s. Bring down my plus 4, and that equals a 67. So we've taken care of our first 4 steps. And those first 4 steps that we take care of, we are just taking care of them on the left and the right. Now we're going to start to move and do inverse operations. And the inverse of that plus 4 would be take away 4. Whatever we do to one side, we do to the other. Our goal is to isolate the variable s. And so we have 3s equals 63. Remember that 3s means 3 times s, and the inverse of multiplication is division. Whatever we do to one side, we want to make sure we do to the other. We want the s all by itself, so we want to divide by the 3. So we get 1s equals, and 63 divided by 3 is 21. Again, we can go in and check and see if we did that correctly. We have a total of 4 examples here. So let's go ahead and look at the next one. Example 3, I've got 3 5/10 plus a negative 0 2/100 x equals 1 24/100. So I think we get nervous with this one because we get freaked out that we have decimals. The process is the same. Draw your line down the equal sign. Change all your subtraction to addition. We already did that. Do I have the distributive property? No. Do I have like terms I can combine on the left-hand side, like add together? No. So we start to move. And we want to get the x by itself. So we want to get rid of this 3 5/10. So we want to subtract 3 5/10 from both sides. And that leaves us with a negative 2/100 x equals, and on our calculator, we need to subtract 1 24/100 minus 3 5/10. We can add a 0 to the end there. And we are going to get a negative 2 26/100. Again, let's not get freaked out just because we have decimals. Let's go through the same steps. Grab your calculator to assist you. And now we know that negative 0 2/100 x means multiply. Put the dot there. What's the inverse of multiplication? So we get the x by itself. It is division. So we are going to divide both sides. Take everything that's by the x. We want to divide by the negative because a negative divided by negative is a positive 1x. Whatever we do to one side, we want to make sure we do the same thing to the other. We can use our fraction bar to represent division. And a negative divided by a negative I know is going to be a positive, and this actually is 113. And we're done. We got 1x all by itself. Let's go ahead and look at our last example. On this example, we have a negative 8, open parentheses, 2x minus 1, close parentheses, equals 36. Okay, let's start by drawing that line down the equal sign. Change all my subtraction to add the opposite. Do I have the distributive property? Yes, I do. I need to distribute the negative 8 to everything inside my parentheses. So a negative 8 times 2 is a negative 16x. Bring down my addition sign. A negative 8 times a negative 1 is just a plus 8. Equals 36. So we've taken care of step 1, 2, and 3. Do I have like terms on one side? No. So we need to start to move and get the x by itself. So the first thing we want to do is do the inverse of a positive 8, which would be a takeaway 8 on both sides. It cancels out our 8's on the left. We're left with negative 16x equals 36 take away 8 is 28. And now we know negative 16x means multiplication. To break apart or to isolate the variable, the x by itself, the inverse of multiply is a fraction bar, meaning division. We want to divide both sides by negative 16. This is going to cancel out. Negative 16 divided by negative 16 is a positive 1x. We can put the 1 there if we would like. That's our ultimate goal, is to get a 1x, or our variable, by itself. And we have 28 over a negative 16. This is what we call an improper fraction. Let's not turn this to a decimal. Okay, we can simplify it to make it a mixed number. You could ask yourselves, how many times does a negative 16 go into 28? And we know that that would be 1 time. So we would have a negative 1. We would have 12 28ths left over. These are all equivalent fractions, equal in value, but look different to our eyes. Okay, if we want to divide 12 and 20. Oh, why did I put 28? I apologize. That should be a 16. Not sure what Mrs. Bora was thinking there. I apologize. I'm glad I caught my mistake. So 16 goes into 28 1 time. 12 are left over. Now if we want to simplify a little further, we can divide both of these. What numbers is 12 and 16 both divisible by? 4. So our answer for x could be a negative 1 and 3/4. Okay, all those fractions are equivalent to 28 over divided by negative 16. You don't need to change it to a decimal, leave it as a fraction. And that's it. Solving multi-step equations.